start. Okay, so I am jumping in. I already did introduce the topic. Again, the three major topics that we're going to go through. Limits is chapter 1, derivatives is the whole rest of the first semester, and integrals will be what we do third quarter. We will be done with calculus at the end of third quarter. When we get to spring break, all of fourth quarter will be AP practice. Okay, my definition of a limit. Let's get that first. All right, it is the height. All right, is your height your x or y value when you graph something? All right, so let's put that in parentheses. So in other words, I'm saying the y value. A function. All right, now here's the key word. And I've heard this defined a lot of different ways, and this is why I'm saying that this is my definition of a limit. Because this is the word that I liked, that really made the most common sense, if you will, for what a limit is. That a function intends. Underline that. It's kind of weird you're saying, well, what are the intentions of the function? But that, when you think about it like that, it just makes sense what a limit is. Alright? That it intends to reach where the function is intending to go as the function gets closer and closer, and closer to the specified x value. And closer to the specified x value. Alright, it's a little wordy, kind of a little weird at first, but it's just the y value that you intend to reach with the x value you're talking about. That's it. Now you gotta, but the thing is, you're gonna see with some applications of this, you gotta add this little closer and closer. Alright? Alright. Say the first one. Very simple, but this is a good introduction to limits. Graph x squared. You guys know how to do that without a calculator. Start at 0, go 1, 1, negative 1, 1. Alright, go forward 2. Well, when I square 2, I'm up at 4. Again, I don't need a calculator for that. When I go back 2, I square it, I'm at positive 4. So very simple. Here's your graph. Okay. Are there any holes, asymptotes, anything like that in your domain? Anything that x cannot equal? No, we're good. You know parabolas. So I'm just giving you this one to get you familiar with the language of a limit. What this question says is, what is the limit as x approaches 2 of the function? All right, so let me say that one more time. What's the limit? So in other words, what does the function intend to reach? That's what they're saying with limit. What does it intend to reach as x gets closer and closer to 2 of this function? Well, here's 2. Here's my function. So look, it's coming up here. It's coming up closer and closer and closer to 2. Here's when I actually get to 2. Here's from the right side getting closer and closer and closer to 2. So there is the height. Let's actually write that word height that I reach when I get to 2. Now in this case, this particular case, not most cases on what a limit is. This particular case, the limit as x goes to 2 is actually the value at 2. This is the exact same question in this particular case of just saying, what is f of 2? Well, what is f of 2? What do you get out when you put in 2 into the function? You get out 4. Alright, so there you go. There's an easy introduction to limits. And you can see it. As the function gets closer to 2, the output of the function is 4. Alright, now that's just an easy introduction. Honestly, there's no way anything like that's coming up on the AP test. We're just getting the idea across to you. Alright. Here's what could come up on the AP test. Now, if you don't have a graphing calculator, go ahead and grab one. And I'm going to get mine. Just set that. Alright, and actually put in that original function into your calculator. So, I'll put in, and when you put it in, I would not use the fraction button on this, because remember, when you input fractions into your calculator, outputs fractions in your calculator, I just put parentheses up on the top and the bottom. So I'm going to put x squared minus 6x plus 8 divided by parentheses x minus 2. So I would put it in exactly like that, where it's actually the parentheses around the top and the bottom. And I'll hit, oh, graph. I'm zoomed in somewhere funky. Remember, you can always get back to your base graph by hitting zoom 6. It'll take you back to that base graph. It says graph just looks like a straight line. With this straight line, it intercepts the y-axis at -4, intercepts the x-axis at +4, actually just has a slope of 1, going up 1 over 1, up 1 over 1, up 1 over 1. So this looks like it's the graph, but anybody, any idea why is this not the graph? What is wrong with this? If you did it back in college algebra, this is something you know from algebra 2, probably got introduced to it in algebra 1, you went over in algebra 2, you went over in college algebra, and now we're doing calculus with it. What's wrong with that graph? Okay, and what's the domain restriction? What can x not equal? Alright, so on this graph right now, it looks like I got a value at 2. It looks like it's -2, but it's not. Now, is that an asymptote? Is it a hole? Is it... Alright, what creates a hole? This is background. Yeah, alright, here's your background. Here's your algebra 1 and your algebra 2 stuff coming up in the middle of calculus. You can factor the top. The top factors is x minus 2, x minus 4. The bottom is just x minus 2. Remember this from college algebra, and again from algebra 2, it was taught in both places, that every time you cancel a factor, what shows up on your graph is a hole. So look at this graph that my graph calculator gave me. It doesn't look like there's a hole, but I taught you this last year. If you hit trace, 2, enter, it says, wait a minute, I can't put a 2 in the original function. It doesn't give me a value for y. It says that we can't do that. That's part of my domain restriction. There is no value of 2. So, again, let's compare these two. In this first one, when it said the limit as x goes to 2 of the function is 4, happened to be the exact same thing as f of 2. Well, if I tried to do f of 2 of this one, it's non-existent. There's a hole there at 2. There is no, the function can't evaluate 2. But the limit as x goes to 2, as I get, again, what does it intend to reach as I get closer and closer to 2? Well, once again, as I approach from the left, as I approach from the right, and there's a reason that I'm saying it with that language we're going to get into in just a minute. As I come in from the left and the right, there's my height. That's the height that I'm trying to reach. That height is at y equals -2. That's my answer. That's the limit as that function approaches 2. And again, that basic understanding of it is going to come up a whole bunch when we get to derivatives. We got to understand this before we can build on it to get to derivatives. Alright. I'm going to have you try example 3, but I'm going to tell you this about it. Again, you just need to understand what the language is asking you. On this one, go ahead and write this to the left of it. When this says the limit as x approaches 2, and this is real easy to get backwards, when it's got that negative sign there, and the kind of looks like almost an exponent of a negative, that is saying as you approach 2 from the left. As you approach 2 from the left. Now, what's easy to do at times is to look at as I approach 2 and think I'm headed to the negative direction. So it's like you're approaching it from the right. You got to get that out of your mind. When it has a negative there, I'm starting out to the left of it and I'm moving to the right. See what I'm saying? It can be a little backwards, so we got to be clear on that. So this first one I'll do with you, and then I'll let you finish these up. The limit as the function approaches 2 from the left. The limit as x approaches 2 from the left. Alright, so here's 2. I want to know what's happening with this function as I come in from the left. Not as I'm headed to the left, as I come in from the left. So here's the left of 2. Here's 0. Here I am at 1. There I am at 2. There it is right there. I'm intending to get to -4. Did I ever get to -4? No, I never got there, but that was my intention. That's where it looks like that function was going, is it was going to -4. Alright, so, let me add one other thing and I'll let you finish that one. the limit as x approaches 2 from the right is that plus sign. This is from the right. I'm coming in from the right, so I'm headed to the left, but from the right. Alright, you answer those others. Answer those real quick. We will have the idea, and we would just need to practice it. Okay, so should be easy on this one as you approach from the right. So here is 2. I'm coming in from the right, so I'm coming from here to 2. I'm at -2. Do I actually get the -2? Yes, you do. All right. Again, that's not the main idea. It's just what are you trying to approach. But it is good to notice that I actually get there, but I don't down here. Okay, so what is the limit as x approaches 2? Well, hold on a second. I intended to go to -4 when I came from the left. So I'm going to draw this little arrow here. I intended to go there. I intended to go to 2 from the right, so which one wins? Neither. They're not the same. So because of this, because the left and the right are not the same, the limit as I approach 2 does not exist. Very key idea right there. This will also come up with later this chapter. We're going to talk about continuity. If something is continuous, that is how you define it. And we actually get to the AP exam. This will be a question somewhere on the AP exam. They will say, prove that this is continuous. How you prove it's continuous is the limit from the left, the limit from the right, and the actual value there are the same. See how the limit from the left and the limit from the right were -2 on example number 2. But was it continuous there? No, there was a hole there. But on example number 1, limit from the left, limit from the right, and the actual value there were all the exact same number. I was trying to get the 4 from here, I was trying to get the 4 from there, and I was actually on 4 on 2. If you can show those 3 things, that's continuity. That's another lesson. I just gave the whole lesson away. That was it. Alright, what about the limit as I go to -2? Alright, I intend to go from the left, I'm going to 4. From the right, I'm going to 4. But where am I actually at -2? I'm actually at -1. So is my limit -1 or is it 4? Alright, this is why I like that word intends. Okay? And yes, Press said does not exist. That it very well, I mean you don't know. I think that, again, that's why I like that word intends. Your actual value is 4. Alright, you were intending to go to 4. You never made it. When you're actually at -2, you're down here at -1. But when the left and the right are going to the same spot, the limit exists. Got it? There it is. That's the lesson. Now we got to practice it. Alright, flip it over. I don't think there's anything new that comes up on the back. I just want you to practice it. I want you to see it and make sure we're good to go with it. Yep. Alright, so I'm going to give you a little bit of time. Try out just do the whole back side. You get the whole back side right, I'm going to go over every one of these answers. I got a short little worksheet with this, and we will be done. Okay, here we go. Limit as you approach 0. What was it? 1. Alright, and that's, I mean, it's continuous there. You can see it goes right through it, actually equals it. Alright, what's f of 1? Good. Reading a piecewise function is going to be a huge part of calculus. Okay, just that you can read this and you know that that's the actual value there. But what is the limit as I approach 1 from the left? Good, very good. 2. As I'm coming in from the left, I'm at 2. What's the limit as I approach 1 from the right? Very good. So what is the limit of 1? Alright, when they are different, it does not exist. Very good. Now again, if they would have approached the same from the left and the right, but I would have been up there for the actual function value, that's fine. It's just when the limit from the left and the right are different, it does not exist. Alright, as I approach 5 from the left, good. As I approach, f of 5, very good. There is no f of 5, does not exist. Good. Bottom one, limit as I go to -2, 0, because from the left and the right I'm at 0. Okay. What about 0 from the right? Very good. 0 from the right is 3. 0 from the left? Yeah, infinity. You can have a limit of infinity. It goes to infinity. Good question. Alright, f of 1. Very good. Limit as I go to 0. Good. I got different answers from the left and the right. I got 3 on one side, infinity on the other, so it does not exist. And finally, limit as I go to 1. Actual value at 1 was 2, but what was my intentions as I was going to 1? Very good. You got it. That's it. Alright.